Hi, everyone. Welcome to today's Destination LoRaWAN webcast. We are going to go ahead and get started in just a few moments here. Thank you for joining. All right. Hi, everyone. We do want to go ahead and kick off on time here. So let's go ahead and get started with today's Destination LoRaWAN webcast, called Ensuring Device Success with LoRaWAN Certification. Thank you for joining. Before we dive in, there are a few housekeeping notes to share with you. At the bottom of your screen, you will see a bar of application engagement tools to help guide your experience. You can also move around and resize the different tools on the screen as you need. If you notice the slides or video is behind, simply pressing F5 on your computer will refresh your screen and help you catch up. Most importantly, you can see the Q&A box below the slides. We are going to have a live Q&A session at the end of today's webcast with the panelists. So please be submitting your questions throughout the webcast into that box labeled Q&A. Lastly, an on-demand version of this webcast will be available within 24 hours, and you can access it using the same link you used to join the webcast today. Lastly, before we jump in, a special thank you, as always, to our Destination LoRaWAN sponsors who help make these webcasts possible. Thank you to MachineQ, a Comcast company, as the Destination LoRaWAN Gold sponsor. And thank you to our two silver sponsors, Birds and Charter Communications. Now let's get into the great content we have for you today. It is my pleasure to welcome our two panelists, Derek Hunt from the LoRa Alliance and Mark Roberts from 11X. 11X is a LoRa Alliance member, and we are grateful for their participation and leadership of today's webcast. And Mark will be joined alongside Derek Hunt, the LoRa Alliance's Director of Certification. And now I will hand it over to you, Derek, to introduce yourself and get this webcast started.
Okay, thank you very much, Megan. It's great to be here and have the chance to talk about the certification. So my name is Derek Hunt, and I am the chair of the certification committee. Really, there's a few things we want to try and cover today, and one of the points I wanted to start with was we've done a survey recently to try and get people's view on certification and what's stopping them and what's helping them. And there were a couple of points that came out of it that were slightly concerning, so I wanted to also make sure that we can address some of those questions that have come up on it. And there was one in particular that I wanted to highlight here, which is a comment from one of our members, which basically said certification is not needed as we're using the LoRa chipset from Semtech. Well, clearly that's just the RF side of it, and the LoRaWAN side and the certification side is very important to our devices and needs to be done on top of whatever testing is done on the pure RF side. And the other comment that came out was just about the regulatory requirements. So within the LoRaWAN, we do lots to adapt the use of the LoRaWAN in that sub 1 gigahertz space, wherever in the ISM band you're using it in the world. So we try and make sure, and we do everything to make sure that the LoRaWAN complies with the regulatory. But that still doesn't mean you don't have to go through that regulatory approval process yourself. So really what I want to cover is sort of a bit more detail about what the certification does cover, some of the benefits that it will bring with you. And then will also be a section where we talk about, and Mark will join us in a bit to talk about the real-life scalability issues with these devices, and some of the things that he's seen whilst trying to get devices up and running. And then we'll come back to myself, and I'll go through what the Alliance is doing to try and help with that process. So if I really start with the benefits, why is LoRa Alliance and why is the LoRaWAN certification so important? really it's to give everyone the confidence and reliability that the devices will work as intended. There's lots of cases where that doesn't happen, and Mark will go through quite a few of those. But the other thing that is clear is if you can find a fault or an issue earlier on in it, it's far easier to fix than it is later on in the life cycle of your device. And also, if you have the marketing approval with the LoRaWAN certified logo, it has that ability for you to be able to promote your device. And really the final thing is poor devices cause performance issues, which actually has a huge impact, not just on the operational side of it, but potentially the cost of returning ones. So the certification program is available to all LoRa Alliance members, and there is a category separately for certification affiliate. So if I go in through what is the certification about, well, the key thing really is this assurance. It assures that the LoRaWAN protocol is adhered to. And one of the key things that we find is it makes it and ensures that it will work under any operator condition. We've seen lots of instances in the past where a device is tested on one network and then goes to a different network. And because they use slightly different parameters or it's a different set of configurations, it doesn't work that way and causes problems. So the LoRa Alliance certification program goes through all the different parameters to make sure that it can work under any network condition. And it also gives us the reliability. So it guarantees to adhere to the LoRaWAN standards, and we do everything we can to certify the device in a normal operating environment. So there's no extra wires or connections you need to it. It's basically as your device is going out the door. And the key thing really is to find those issues before you get into production. So it helps save time as well, because we do it's one-day testing at the certification test labs, unlike a lot of the telecoms products, which are usually weeks or months. And then we use an automatic test system to maximize the coverage within that time frame. So really the cost-saving benefits is it reduces your design rework cycle and helps keep the maintenance costs low. And we have worldwide testing solutions, and I'll talk a little bit about some of those so that you can know exactly where to go. What we've also implemented is a separate RF testing, and I'll talk a little bit about that and what it covers. But that's really to help when you're deploying a device to know what performance you're going to get out of it. And it makes it quicker for you to deploy your network. And the final one, security, is a big issue for all of us. So we test and we guarantee that everything in the LoRaWAN from a security point of view is covered by that certification program. So just going a little bit of detail of how it works. You see from the picture in front of you, we have the device under test, the DUT, which is really your device you're trying to certify. It runs the LoRaWAN protocol stack, and it's connected to a gateway. And this is a standard off-the-shelf gateway. Again, everything's been done to keep the price and the cost of certification as low as possible. So it uses a standard off-the-shelf gateway. And then it connects up to a control layer. And that control layer is either the LCTT, and I'll talk a little bit about that later, or it's a defined and determined one that the authorized test houses have put together. But basically, when you're going through certification, it supports all of the different modes of operation, as I've talked about, so whether it's over-the-air activation or activation by personalization. And really, it does it in an anechoic chamber, so you have the advantage to guarantee the rate, and that's for a couple of reasons. One, it gives you the repeatability because there's no other outside traffic to do it, but also one of the tests that we do is actually to test the packet error rate. So we want to make sure it's the device's performance that you're measuring, not whatever background noise or interference it causes a problem for the device. And the whole process sends and receives over 2,000 messages. So in terms of authorized test houses, we have 6 authorized test houses. They have locations all over the world. And really the key thing with that is it's trying to ensure that if you have a device that you want to be tested, it can be tested as locally as possible to you. And because the ISM band is different in all parts of the world, the certification itself is against the different regional parameters. So it's trying to make sure that You can test, for instance, in North America against Europe, or you can test in Asia against Europe or North America. So the test houses also have the ability not only to test locally in their region, but they can test for the region that it's going to be deployed to. And in terms of you as device manufacturers, the only cost you pay for certification is the fee you pay to the authorized test house. Unlike a lot of other alliances, the LoRa Alliance does not take any cost for issuing certificates or giving you certification from it. So that is free to all our members. So finally, just a quick run through. Once a device has been certified, we then publicize it and promote it. And for those people who've seen, we have a showcase on the LoRa Alliance website where we go through and highlight all of the certified products. What you can also do on this website is then search for the different region of LoRaWAN that you want it to go for, and also the different regional parameters that you want it to do. As well as there's a feature in here as well now where you can look at it and filter it by the RF performance that you need for the device. So all of those things are here on the showcase. The link is on here, but it'll be in the slide set when we follow afterwards. So really, that was my quick introduction to the certification. If you've got questions and you want to which you want answering, please submit them while we go through. But now I will hand over to Mark Roberts, who can go through some of the real-life issues that they've seen during that process.
Thank you, Derek. I'd like to introduce myself. I'm Mark Roberts from 11X. I joined the company about a year ago to start the Center of Excellence. And in the Center of Excellence, we offer specialized engineering services around LoRaWAN, and especially some best practices testing that we've found useful as a network operator, and what we will talk about today. So I think everybody recognizes the benefits of LoRaWAN. It really has unlimited potential. In 11X's case, we started to create a Canada-wide network about 5 years ago. And after determining that LoRaWAN would be the best overall solution for low bandwidth, low power IoT solutions. And I say that with most of our engineers coming from a cellular background. So initially, 11X tried to deploy with cellular IoT and ended up moving towards LoRaWAN for our Canada network. But LoRaWAN solutions fill a significant gap in the market, but only if the solutions work flawlessly and scale into mass deployments. And so that brings us to one of the problems in the industry today. Many devices fail to deliver on the promise of LoRaWAN. We've found in field deployments that we've encountered many issues that limit scalability. And scalability issues include things like basic device functionality, the performance, the interoperability, the reliability and robustness of devices. We've seen problems that range from drastically lower than expected battery life to basic stability issues, connectivity issues, inadequate security, and many of these issues turn up in device deployments and aren't practical to test at the certification stage. So in our first suite of testing, some of the common problems we encountered in the field, we found that no device passed all of the tests that we did, and no test was passed by all devices. So clearly we have a device quality problem, and network operators must do their own testing and qualification of devices for field deployment today. So going through some of the issues, I would say the number one issue that we encountered was device documentation. Documentation we typically found that only about 40% of the information required to execute our tests was provided by the device maker. And when you contact the device manufacturer, often they provide incomplete feedback. And I think this can be traced to the fact that in many cases, they are subject matter experts in their sensor technology, but they've used modules or contracted services to get their LoRaWAN, and so they don't have a complete understanding of it themselves sometimes. Device provisioning was difficult. And a typical North America requirement, like setting a subband, was not always supported by the device in a reasonable or convenient fashion. Security is still very loose. We see devices coming with blank keys or simple formulas for their key creation. The mechanisms that makers have today for key distribution is very poor. And when they do use QR codes, there's inconsistent use of QR codes across the industry. Now, Derek, in the next part of the presentation, will be talking about how to address some of these issues. And in this first case, the LoRaWAN certified supplementary information that they have in place for EU network operators, that's a very important initiative that I think needs to be realized in North America as well. Another big issue, and what represents the biggest part of our suite of tests, is connectivity corner cases. Now, Derek mentioned in his introduction there that LoRaWAN certification testing is necessarily limited to a reasonable time frame. You have to keep this certification process economical so that it can be widely adopted. But some connectivity issues appear only in long duration testing. And some questions you might ask is, what happens when a device loses downlink? So we do a 5-day test for that. How many uplinks are actually performed each day? That's a 48-hour test. How well does the device follow the retransmission backoff guidelines for joining? That's a 36-hour test. And dev-announce repetition is many, many power cycles of the device and 20 join requests each time. Does the device work properly on all the data rates that they claim to support? So to give you some anecdotes on these, in the case of loss of downlink, we've typically saw a failing device transition over time down to data rate 0, but then they go silent. They don't try to rejoin again. So that device can be lost. If you have a remote gateway outage and you don't get it repaired in time, you could lose large swaths of devices that you would have to then roll a truck and reconfigure and get onto the network again. The number of uplinks, there's an unpredictable number of uplinks by many devices, and that becomes a scalability issue in mass deployment. So we like to see a very predictable number of uplinks, typically. And in retransmission backoff, that join test, a lot of devices don't follow the time on air specifications. And it's not until like the 11-hour mark that we see them start to fail and diverge from the requirements. And also, when devices are joining, you really need to thoroughly check whether they're using all of the channels and check that they use the lowest data rate to join. And some devices never use the 500 kilohertz channel, for example. So those are all issues that we've encountered in the field. The dev-announce repetition if you see a device fail in that area, it's probably traceable to the same LoRa stack and the same MCU combination where, for whatever reason, the pseudo-random number generator wasn't good. And so we do see a number of devices in the field today that have dev-nonce repetition in their join. Strange join behavior, what I mean by that is there are a number of devices out there that will join the network and then remember those settings forever, even if they're powered off. So this could be an issue. I mean, they become like an ABP device then. This could be an issue if you reconfigure your network and you expect the device to rejoin and get a new network address, for instance. So some unexpected behavior there. Now, another big issue for, I think, everybody in the industry is the battery life. It's one of the biggest offers that LoRaWAN has, is a really long battery life. It's very reasonable to expect to achieve the battery, the shelf life of the battery in deploying devices that have power efficient sensors. Having to go out in the field and replace batteries could destroy the economics of a mass deployment. And devices, unfortunately, fall short of their claims in the area of power consumption. So we feel that many manufacturers are quite optimistic about their battery life, maybe choosing a best case scenario. But when you look at a practical mass deployment, you have to allow for devices being somewhat removed from the gateway. So you need to pick a typical worst case and use a fairly low data rate, have a reasonable activity level from the device. And so we've incorporated all of these things into our battery life estimate testing that we do. We've lately integrated the Nordic Power Profiler 2 into our test setup, and we found that with its 100 kilohertz sample rate, averaging those data points in real time gives excellent amount of detail to debug problems with the device, and also gives a very good battery life estimation. Finally, there's issues with network interoperability, and this is becoming a lot more important as the details of roaming and broker systems are worked out. The bottom line is, LNSs, so it's the top line in this slide, LNSs are not standardized or certified, and there's a lot of subtle differences between LoRaWAN network servers due to the interpretation of the specs or the philosophy of the network server creator. Network servers are slow to change, and often they haven't adopted the newer features in the standard that resolve legacy issues. A couple anecdotes in this area. Our own network server is OrbiWise that we use, and in the early days of the standard, there was some interpretation required by the device when they received multiple MAC commands in a single packet. So typically it would be like ADR link commands. And so OrbiWise had to restrict the use of ADR link commands so that you wouldn't put the device in the situation where it executes the link commands in the wrong order and then ends up ignoring commands because it would shut off subbands, like all the subbands, and disconnect the device from the network. Or alternatively, it might actually go ahead and execute the commands in the order that it feels is right, and then end up disabling the device from the network. Now that has subsequently been improved or worked around in the latest versions of OrbiWise. They they put the ADR link commands in a specific order so that there's no chance of misinterpretation, and they tend to want to see you turn on new subbands first before you turn off any subbands. So that resolves that issue. Another network server we've seen some issues with is ChirpStack. So we use ChirpStack internally a lot in our testing, and 11x tends with our meter interface unit. We want to run in confirmed packet mode. It turned out to be the most efficient way to run that kind of device. And ChirpStack interprets the re-acknowledgement of confirmed packets as a possible attack vector for denial of service attack. So somebody could replay the confirmed packet and use that as a way to deny service by getting re-acknowledged on those packets. So ChirpStack just won't issue re-acknowledgements. And if you are a device that runs in confirm mode, that could be a serious problem, because if you're out on the fringe of the network and you lose one packet, then you're kind of forced to go into a mode where you try to replay or get that packet re-acknowledged up to 8 times. And that's a drain on your battery and your overall system, especially if you're in mass deployment of sensors. So finally, as I said at the outset, 11x has this Center of Excellence, which offers a number of specialized engineering services and importantly, some best practices testing. And what made this possible is Semtech's open source, open hardware project they call the Conformance Test Bench project. So we've taken that and we've customized it and extended it with our own test suite. And using that setup, we have the option of internal or external gateways. We have integrated ChirpStack on the Raspberry Pi that's part of that setup. The CTB becomes a man in the middle, so it's very flexible to let us inject commands to the device for advanced testing. And with this suite of tests on the CTB platform, they're kind of a fleet of devices that you saw in an earlier picture. We've started to bring something like a carrier acceptance test program to LoRaWAN that you might be familiar with from the cellular world. So I'll pass it back to Derek.
Okay, thank you very much, Mark. So what I wanted to do really was just try and go through some of the issues that Mark's raising, and we have seen those issues as well, and trying to look at what is the Alliance doing to help and what can we do from the certification to help that process. So really, I'll just run through a few of the initiatives that are going through, and some of them you may have heard of, some are just literally coming out over the next few months. So I'll talk about the LCTT. Mark talked a little bit about the back-off text mechanism, so there's a change to what we're planning on doing for that, and we're implementing that fairly soon. Then I'll also talk about some of the other things that operators have seen in terms of the performance of the device, the RF performance. But then I also want to talk a lot of work that we've done with the European operators, really to try and address a lot of the issues that Mark's seeing in North America, and also go in to talk about this extra information that's needed by the device users to effectively set it up. So if I start with the LoRaWAN certification test tool, I was asked from when I first started this certification program, and we first started rolling it out probably 4 or 5 years ago now, to have some sort of ability for device manufacturers to test their device prior to going to certification. So it's really been designed from the ground up to allow that feature. And what we've done is we've kept it in step with the certification program. So it tests all the features and functions of the LoRaWAN protocol, very much as you would do when you're testing your device at an authorized test house. But it also is capable of running at your own facility. So you don't have to take it anywhere, you don't have to do it. You can set it up in your own lab, in your own office, and actually run through it. So this gives you the time and money saving by allowing you to fully test your device prior to going to a test house. But more importantly, it accelerates the process that it takes you to get through from, because what you really want to do is get your device to mass deployment. And the tool itself is available for both 1.02 and 1.04. So just a little bit about how it works. What you can see is the setup here is very sort of similar to what I described earlier with certification. We have our device under test. Again, we use a standard local gateway. And then the LCT tool itself is downloaded to you via a PC, and it runs on a PC, and that PC really has a mini network server built into it and the test control layer. And what it allows you to do is have two modes of operation. So we have a mode in it which we call pre-certification, and this will automatically run through all of the tests that are needed when you go through certification. There is a slight difference in that to keep the cost of this deployment down locally, we're expecting that most people would just implement it with effectively an 8-channel gateway. But obviously for testing for North America or for Europe, now you might need a 16 or a 64-channel gateway. So it does all the tests that it can do with that limitation. And then the final mode it has, which is the one really most the device manufacturer have found useful, is this debug mode. So if you run through a certification test and you find it failing, you can stop the test, you can rerun that specific bit of the test, you can put it in a loop to allow you to just repeatedly run the particular bit that was failing to help you try and diagnose what the issue is. And the way it's set up is it provides you all the logs and the data, so you can see every message that's been transferred, sent and received by the device. And there's also the ability, if you want to do other things to your device, it can send and receive MAC commands from it, so it gets the responses back from it, so you can set it up in a particular manner that you want to do. And this tool is available to all LoRa Alliance members. It's part of your membership benefit, and you get that to run on your local PC. So it really is a local way of testing it through all of the life cycle of your device. The next one I wanted to talk about was, and as Mark mentioned, we've had issues raised with what we've sort of locally termed zombie devices, and these are ones that sit out in the network and are just continually sending join requests. And as Mark says, that test is a 36-hour test to run. So clearly it's not feasible to include it within the certification test. The cost of running that at an authorized test house would just become too prohibitive to do. So what we're just introducing and will be rolled out in the next month or so is a test mode in the LCTT that actually allows you to run this test before the device is certified. And then once you've got the results out of it, you'll send those results with it, with the device you want to be tested, to the test house, and it will be included as part of that certification process. So with this, we now have the ability to run some of those longer tests that Mark was referring to. And what we can also use is looking forward to say, well, are there other tests that we could look into putting into this? But certainly this will become part of the certification process within the next 3 months. So the other thing that's really critical for a device is the RF performance of it. And you can see from this, if you want to get the best performance out of your device, it really isn't, it is critical that it has a good RF performance. But the trouble is, a lot of our devices, they are really ones that can either be mounted on a desk or put on a wall or put in a certain configuration or orientation. And what's really been useful, and this is what was really requested by the operators that we've worked with, is not just to have what the output power of the device is, but to do a 360-degree scan of it, so that when you see the test results from this, not only can you find out what its maximum power is, but you have the ability to be able to say, well, okay, if I'm going to mount this on a wall, this is the area that will be facing my gateway. This is the RF performance I expect to get from that. So the measurement it does is looking at the transmitted power, and I said it scans it over a 360-degree ratio to find the different points of it, and it captures all of those in the test report. What it then also does is say, okay, well, transmission is one thing and the effective radiated power is one, but what about its sensitivity? How good is it receiving? So what it will do is it'll pick the area where you had the most stable position of the device and now actually use the LCTT or a test tool to send packets down to the device and slowly reduce the power coming out from the gateway until we get to the point where we have a 10% packet error rate on the device. So that gives you then a really good view of the sensitivity of the device as well. And those measurements are the ones that the operators in particular have requested us to do. So we have created a best practice document on how to measure this so that all devices are measured in the same way. And more importantly, you can compare one device with another. So that's the RF performance. The other thing, and Mark mentioned a little bit about this earlier, I just wanted to talk about. We've done a lot of work with the European operators who've been seeing exactly the same sort of issues that Mark was talking about, of different network servers behaving slightly differently, different parameters set up, and the device will work with one set of parameters and not with another. So what we've worked with them is to create additional tests that have gone into, and for Europe, they've gone into the 1.02 certification requirement specification, but all those additional tests have been included in the 1.04, so they become relevant for everywhere, all the regions. And that is a list then of all the additional tests that the operators had seen that they were needing to do to try and find and resolve the issues similar to what Mark was referring to. So we've enhanced and incorporated those into the certification test. And so now what the operators are asking us to do and are asking of their device manufacturers is to come back and say, yep, it's been certified against either the 1.02 latest version or against 1.04. The other thing that they're saying is critical to them is this RF performance test. And again, if you have a badly performing device, it has a real impact on your network. You may need twice as many gateways if the device doesn't provide the power output that you're expecting, or it may be running all the time at a very slow data rate, and in which case it will impact the battery life. So again, this is critical for them, and they've insisted that it's all done before they'll go into mass deployments. And then the other thing, and I'll just mention this on the next slide briefly, is this information that's required by operators to set their device up. It always seems a real shame to me. You've done all the hard work to produce your device and you've got it out there and you've got it marketed, but you don't allow the operators all the information that they actually need. And I'll just, on the next slide, I'll run through some of the things that we've incorporated into that to try and make sure we get it. So really the benefit, and this was the real main benefit from the European ones, is device manufacturers prior to this were going to the different operators. They had their device passed by one acceptance test and then it failed on another one. So they were always having to go back and rework it. With this, they can go through the certification and then it's accepted by the operators. So there's a considerable time and effort saved in there. So really, it sort of simplifies and speeds up the selection, and this is what we want to try and roll out, and the intention is to roll this out now as well for North America and other parts of the world. So what I spend and just go through really is, what is this additional information? What is the important things that are needed by an operator or a user of a device to try and make sure that they have all of the information in one place? So it sort of fits into four main categories. The first thing is just the generic sales information. And again, it's amazing how many devices are out there, but you don't really know who to contact, who to get hold of. So this is a questionnaire that's been designed by the European operators and incorporated into the LoRaWAN certification program, where we collect all of the information that they need in order to deploy their devices. It then goes on to the device itself, and it talks about the DEVI-UI range and the power schemes used, and again, different versions of these devices, whether they pick one regional parameters or another, have slightly different power schemes. So this captures what you've implemented for your device. And then the final one is, or the information is about the gain, the antenna, what antenna you meant to use with it. So again, this is a little bit more information. And then the final one really is the battery consumption estimates, the measured ERRP, and the sensitivity figures for it. So really with that allows them to have all the information they need to set it up onto their network. And that information as well is also stored on the showcase. So when you click into a device, not only can you see the certification certificates for it, but you can get to this information sheet, which gives you all of that extra information. So really, finally, just to come back to this, this is really why you certify your device. And again, it's the confidence, the reliability, reduced support costs, marketing. And the other thing that I wanted to bring out at this point is, we've heard it time and time again, operators are prepared to spend more for a device that has proven reliability. So you can try and keep the cost down as much as possible, but if you run into issues or problems, then the operators are soon going to know that. And in most cases, they are prepared to pay a premium for devices that they have confidence with, that are capable of running it. So that really goes through everything I wanted to discuss about that. A couple of last things then. Just really talking about, for more information on the LoRa Alliance and membership, and to become part of the ecosystem, you can download the membership information that's in the resource box on the console. And you can also reach out to the email addresses on there to get any questions you have answered about it. And then the final one is, this is part of the long series that we're doing about LoRaWAN destinations. They'll be having new content every week throughout the next few months. So please check the Destination LoRaWAN website or engagement hub to try and see. And the final thing is, we will record this session today, and within 24 hours, we'll put it onto a demand for replaying back, and you can follow the same link that you saw today to get access to it. So at this point, we'll hand over and we'll start the sort of submitted questions and answers boxes. We've had some great questions in, and what I'd want you to do really is just hold on a few minutes, just a minute or so, while we collate all those questions, and then start in thoroughly the question and answer section. So hi, thank you all for those who've joined. So we're now moving into the question and answers section. Again, thank you for all the questions that have been submitted. If you have any more, please do submit them by the Q&A box. So what I'll do now is start running through those questions that we've received. I'll try and cover most of them in the order that we have. If I can see a couple that look like they're combined, I'll try and talk to them as well. And I'll also get Mark to answer them where appropriate. So starting on the first questions, when really about the ST device, the IQ LoRaWAN, asking about certification. As far as I'm aware, that's part of the STM32 WLES series, which has had substantial certification testing done on it. So I'm not sure specifically the IQ, but certainly ST are heavily involved in the certification program, and I would expect that to be dealt with. So next question is, what's a typical test cost time charged by the ATHs? Does it greatly vary by region? So one of the things that we try to do is keep the time that it takes to actually certify a device down to the minimum. And although we don't, as an alliance, don't have direct control of the cost, what we do have is the ability to control the time of it. So we have made it to the point where all the devices will be certified within a certain period of time, and that varies slightly by region. But again, if you go onto the LoRa Alliance website and look at the ATH test houses bit in the certification one, we give you an example of what the typical times would be for you to get your device certified. And there may be some regional variation, mainly because obviously hourly rates change from one region to another. So we try and identify things by the time, but then not specifically go into the price because we're controlling the time of the device. So next question was, what is the addition? Why not add additional multi-day testing to the LCTT? And thank you for Carlo. This came in when the first section was on. Hopefully we've been in and talked about that now, that says the LCTT now, because it's available to all our members, it gives you that ability to actually run those tests now as a standalone device before it. So what we are implementing is that back-off test where before you send your device for certification, you will run that 36-hour back-off test at your own facility. And then once you actually have that test results, you will forward that along with your device to the authorized test house when it goes through certification. And what we're expecting is that now that everyone has the access to the LCTT, over time there could be other things that we can look at doing and saying, okay, what other testing should we be asking people to do? And to pick up some of Mark's points, there could be other things in there as well that we actually need to try and make sure we can capture into that. But I think the LCTT is the platform that allows us to do that. So thank you for that question. The next one's a little bit more detailed, just about RF testing. When using one of the Semtex chips combined with one another's, is it possible to get the device to do continuously enabled receive and transmit for different channels? Clearly, some of that would need to be a dedicated firmware on the device, but once you have the device talking at the LoRaWAN side of it, by using the LCTT, there is a test mode or a manual mode in the LCTT, which will allow you to send commands down to your device to enable or disable particular channels. So it may not be able to be done directly during the development testing, but certainly once your device is there and operating against the LoRaWAN side of it, the LCTT has the ability to really go in and control and set up the end device. So just moving on, another question then, and thank you for this one. What sort of loss rate should we expect? So typically, the LoRaWAN works over an ISM band, which has lots of other devices in it. I think typically we would expect that you should be able to cope and you should be able to design your network to a sort of up to a 90% packet success rate or a 10% error rate loss. When we actually do the certification, part of what we test is the device's ability in a quiet environment. So we guarantee and we ensure as part of certification that there is no more than a 5% packet loss on the end device. So typically you should be expecting, worst case, to see something in the region of 5 or 10%. But again, the protocols are built into the LoRaWAN to allow you to automatically retransmit messages and things and use the confirmed and unconfirmed message. So I think that's a good way of counteracting anything. And the other thing obviously is if you send one message, it might only have a 90%. If you send the same message twice, you get a 99% chance of success rate. So that repetition again is built into the spec, and if you need to in certain circumstances, you can enable that function automatically. So I have another question, which is how long does it take to run a full test suite using the best practice testing? And Mark, if you want to have a go at that one, please.
Yes. So what we use is kind of a fleet of low-cost test benches based on the Semtech CTB project. And so what we typically have done is ask the vendor to provide 3 samples of their sensor, and then running in parallel on multiple CTBs, some of which are RF chambers, others have the power measurement hooked up. We can complete our complete suite of tests in about 2 weeks of elapsed time by kind of compressing it down. So even though we're doing many multi-day tests, taking advantage of running some things in parallel, we can get a device tested and reported in in working days. Yeah.
Okay, thank you for that. So I'll carry on with a few more of the questions. So are there any viable off-the-shelf local LoRaWAN gateways that can be easily connected to the LCTT? So the one that we are currently recommending is the Semtech PicoCell. That is a little USB connection that fits into your PC, and it really is the best low-cost device that's available for the regions around the world. And again, if you look at the handbook for the LCTT, there's instructions on there, and it points you to various places where you can obtain it from, and it's available by most of the stockists still. We also provide the setup for it so that you can have an easy connection to the LCTT. The reality is the LCTT should work with any gateway, but obviously each gateway has its own slight differentiating. So we have tested and proved it with the PicoCell gateway, but it is possible, you're a little bit on your own, but it is possible to get it set up with almost any other gateway. And I think we've had various people now around the world using it with different gateways. But the one we're recommending and the one we provide all the setup information for is for that PicoCell. So thank you. Another good question says, what about test run with duty cycle on and off? So part of the certification program, obviously, and obviously duty cycle is for the dynamic channel plans. Whilst we're actually doing the testing, and especially when we do the packet error rate testing and things like that, we do go in and turn the duty cycle off, basically to allow us to get the test time. So it's always a compromise between getting the test time down to 3 or so hours. If you can imagine, when we're testing the data rates, for instance, we're sending 60 messages for each of the different data rates on each of the received channels. So there's a lot of messages that get sent backwards and forwards. And if we were limited by the duty cycle, that would take that test time from 3 hours to probably nearer 10 to 15 hours. So we tend to run some of the tests with the duty cycle disabled. But in general, and especially at 1.04, we've tried to use the device now as much as possible in its normal operating mode, and only when there's a specific test that might be an issue from a timing point of view, would we actually go in and, through the certification application, turn off the duty cycle. So the next question is it possible to obtain certification for only the antenna in LoRaWAN? So as a standalone, it's not possible to certify it or test it, but obviously once it's connected to a device, and it could be any type of device that accepts an external antenna, what is available then is the RF measurement, the end device measurement facility, and that defines that set of measurements, and it provides that 360-degree scan. So although you can't test the antenna in isolation by attaching it to an end device, and then you can actually use the end device and run through the testing mode with that so that you can actually see what the performance is. And obviously at that point you could switch out different antennas as well, so you could be clear what's the impact of the antenna as opposed to just the end device itself. But as you know, the radiated pattern is more specifically there to test the antenna. So a lot of the end device RF testing is specifically aimed at testing the antenna on the device, whether it be an internal one. So the next one was a follow-on question about antenna patterns, even if it's internal, to know what orientation the device is when it's placed. So yeah, this was one of the things that we added again specifically when we're working with the operators, because the antenna does have a significant impact on the range of the device. And once you impact the range, you're then impacting the data rate that the device is able to do. So it's not much good having a device if it works absolutely perfectly on your bench, and actually you're going to wall mount it, because then its transmission mode will be in a completely different orientation. And that was really the aim of doing the RF performance testing, to make sure that we cover and we capture all of its abilities in all directions, so that and one of the things particularly the operators look at is when they look at the 3D scan, they actually check how it's going to be mounted and where it's going to be mounted, so that they can actually make sure that the output power that it's giving is based on the orientation they're actually going to install it in. So the next question is, where can I get an LCTT on the market? So I'm not sure if you're a LoRa Alliance member, but if you are, it's free and available to all LoRa Alliance members. It is a benefit that we have said for the LoRa Alliance. And what we can do, if you are a member, then please come back to us and I can tell you exactly the links where to get it from. But effectively, you would just download the software package from the LoRa Alliance, install it onto a local PC, which could then run as the LCTT, and then effectively go through a process where you extract a license file, which you send to the LoRa Alliance, so that we can then send you back and basically enable that license on that PC and able to run that LCTT. So it's not available outside of the Alliance, it is only available to LoRa Alliance members. And obviously there's two ways of getting that. Then if you are a member, fine, you're welcome to it and it's part of the benefit. If not, there is the process called the certification affiliate, which will allow you to go in and become a certification affiliate, which is not signing up to the full terms and conditions of the LoRa Alliance, but will separately give you then access to the LCTT. So if you're interested in that, please follow up again with us, and the addresses are all on the slide set as well. So next question, this is a good one, thank you. So what are the best practices for testing LoRa devices in field conditions? I think there's a little bit in that of there's a lot of work that's sort of been done, and that's a lot of reasons why the RF testing is so important for it. Obviously the conditions, and we know different buildings have different absorption rates and things like that. So what we would actually suggest is that you actually do just a trial of where you want to put the device. And it's a combination really of where is the device going to be located? Is it indoors? Is it outdoors? How far away is it that you're expecting the device to be from the gateway? And this is one of the things that, again, of the RF testing that we've put into place is we quote having measured it, we actually say then what is the expected or what is the likely output power that you're going to get from this device. And that has the biggest impact into then what is the range that it will be able to reach and how far will it be able to go. So the best one really is look at the situation and define where the gateways are and work out what devices, where they need to be inside a building or not. So the next one is using a LoRaWAN radio module automatically certifies the whole device. So what we've implemented is the certification by similarity program, and I didn't really talk about it on the slides, but we have, if you already use a certified module, and the main thing is that includes the LoRaWAN protocol stack, then you can implement that onto your own device. And with that, you can then apply for certification by similarity, which means you don't need to send your device in. You fill out a self-declaration form from it. You submit the information and it goes just through the authorized test house for them to check it. But if they're then happy with it, they pass it on to us. And then we can issue you a certificate or to say it's passed the certification test based on that certification by similarity. But the key thing is if you meet the criteria for that, and using a certified device is one of them, it will go through and won't need to be separately tested. I'm just trying to think if there's any others to pick out. There's quite a few questions in here. I'll carry on for a couple more minutes, but I think I know we then need to pull a halt at some time. So one question I think covered something similar to that is, do you intend to include a standard generic gateway in the LCTT? And that's partly what we've tried to say would be the picocell gateway from that. So the next question is, we have an LCT dongle that runs on 868. Do we need to buy additional dongles for other frequencies as well, particularly looking at AS923? So AS923 works in the 920 mark. The reality is the dongle, and especially I know that the picocell from that will actually work at those other frequencies. It's a matter of reconfiguring it. And because we're only doing LCT testing, you're going to be quite close to the device. So there is a good chance that the same gateway will work. But obviously you need to be aware that depending on where you are, you have to transmit legally within your band. So if you're trying to use a band that's not part of your country or your region, then you need to put it into some sort of Faraday cage. So I'm conscious we're coming up to time. I think we're probably a minute or so over now. So I'll call a halt on these. Thank you all for those who have submitted the questions. Those that I haven't been able to answer to, we will go through and separately respond to and make sure everyone gets an answer for that. So with that, thank you all for attending. And thank you all for the brilliant questions that have come in, and we will come back to you with the answers specifically for those that I haven't been able to do. So thank you all very much, and hope to see you again soon.